let us consider the steps on how to create our inverse trigonometric functions, alright? So we're gonna need these for such. Let's read out step number 1, okay? Zach, go ahead. Make sure
given f of x is 1 to 1.
1 to 1, alright? So when you say 1 to 1, you're gonna do a horizontal line test. When you do a horizontal line test, it's gonna intersect or cross that graph at exactly 1 point, right? So we have in here examples of sine, cosine, and tangent. So what we're gonna do is to highlight first a portion of the function that will make it 1 to 1, right? So for the sine of x, what part of the function should we highlight or consider to make this 1 to 1? So let me just use this highlighter. Right? So as you may notice in here, if I just choose from this point to that point of the graph, then it's gonna make it 1 to 1, right? The rest, I'm gonna remove those already, right? So with that being said, then that means for it to be 1 to 1, I'm gonna restrict the domain from where? And range, right? So the domain in here would be restricted from where to where? From, what is that? Negative pi over 2 to pi over 2. Get it? Right? So this is the domain, negative pi over 2 to pi over 2. What about the range? Jillian, what do you think is the range for this part of the domain? The bottom and the top y values, negative 1, right? Get it? Okay. Now what do we do after that? So we have already considered a part of that sine function that will make it 1 to 1. What do we do then? So let us draw that one in here. How does it look like? Okay, so in here, does look like what? Well, it's already there, right? But later we're gonna draw that one in here, right? Step number 2. Let's read this one. Candle, go ahead.
Switch x and y. Typically draw y equals x line and draw
The curve, symmetric to that one, right? So we're gonna draw in here. So you know what? Let's do that one in our Desmos and see how it does look like on our end. So it'll be you know, a better graph for such. So okay, what's this one? Okay, go to Desmos, graph it in here. Y is equal to what again? Sine x, and we basically just consider what part of sine x in here. Okay, so I'm gonna put it in a curly bracket. We said what? So negative pi over 2. To what? X value. To pi over 2. Are we good, guys? Right. So that's basically what we are considering, right? And with that being said, we said our x-axis or the domain was thus just translated from where? From negative pi over 2 to, what's this again? Pi over 2, right? So since that's the case, the step is by pi's. Get it? And our y is from bottom to top, negative 1 to 1. Good? Right? Now, we said in there what? Typically, we draw a y equals x line. So let's draw that one in here. Y is equal to x. Okay, so you see that line. Okay. And then after that one, what we're going to do? We're gonna draw a line symmetric to this y equals x line, right? So let's see how it's gonna look like. Okay, so let me X this out and see. Again, we're gonna draw a curve that's symmetric to that red along that y equals x line, right? Okay, so let's color it what? Let's color it yellow. Okay, so what are the typical points in here, right? So we can say that, so we have this one, we can have this one. What are some exact points in here, right? So we can have this one as well, right? And then in here, we can have some in here. So we can just visualize how it does look like, right? And with that being said, we we can graph it like such. Are we good, guys? Right? Does that look like our inverse function? Okay. Also, we can verify if that's actually our, a good approximation of our graph. So I'm gonna put in here what? X is equal to what? Sine y, and see if the yellow graph that I did is actually similar to this. A little bit. All right, good. We can also graph in here y is equal to sine inverse, right? I'm gonna go in here, go to functions, and click on sine inverse of x, and see that the purple and the green are basically just the same. Are we good, guys? Right? Now, with that being said, since a while ago we said that the domain for x is what? Negative pi over 2 to pi over 2. And since we flipped that one, what do you think now is how is that gonna affect the domain of our sine inverse and the range, right? So if the domain of sine x in there is negative pi over 2 to pi over 2, what now will be the negative pi over 2 to pi over 2 here? Is it the x or the y? Again, we switch it, right? We switch them, so that means in here, the negative pi over 2 to pi over 2 turn out to be the what? The range, right? And the domain now will turn out to be your what? Your negative 1 to 1. Very good, guys. So as you may notice, you can write it in either interval form or inequality form, whichever is needed. Are we good? Right, so let's see. So as we can notice in here, what we're gonna do with this graph is to change this one and actually make your what? Your x-axis as the domain instead, negative 1 to 1, okay, in terms of 1, and my y-axis is the one that I'm going to put as negative pi over 2 to pi over 2, right? So as you may notice, we changed them simply because you flip the x and the y-axis. Are we good, guys? And now with that being said, how do we graph this one out, right? So to graph this one, so the domain is negative 1 to 1. The range is what? Negative pi over 2 to pi over 2. And how does it look like? We said it looks like this one, right? So from here, including that, we're gonna go here up to that. Get it, guys? Right, so that is the domain and range for sine inverse. Okay, so we're gonna do the same for cosine, right? So going back to our cosine, looking at our cosine in here, where is it? Okay, there we go. Annotate, okay? So in here, it looks like our graph looks like that. With the domain and range as follows, right? So the domain in here will now be what? Negative 1 to 1, right? And the range will be what? Negative pi over 2 to pi over 2, right? So as you may notice, it was already flipped, the x and the y. That means the domain and the range. Now, for the cosine, what do we do with the cosine to make it 1 to 1? What should we highlight? So as you may notice in here, I'm going to highlight from here to there. Good. Good, guys. So with that being said, what's the domain for that? And the range for that? So what's the domain? 0 to pi, right? So the domain in here is 0 to pi for the x. Now what is the range in here? Basically the same, negative 1 to 1. Right? Now with that being said, what do you think will be the domain and the range of the cosine inverse? So you're going to flip them, right? Okay. Now this will be what? What's the domain and range in this case then? I'm using an interval notation, but again, you can write it in either inequality notation as well, if you want to, right? So what do you think is the domain for cosine inverse? Negative 1 to 1. Very good, right? So as you may notice, that's negative 1 to 1. What do you think is the range for the cosine inverse? Anyone? 0 to pi, right? So again, as you may notice in here, we basically flip them. So with that being said, what is this point, by the way? At 0, 1, okay, so as you may notice in here, that point 0, 1 in here, on the inverse will become what? If you flip the 0, 1, it will
1,
become
0?
1, 0. Very good, right? So what's 1, 0? 1, 0 in there. Right. Okay. And what is this point in here? This other point in here?
Pi negative 1?
Pi negative 1. Thank you. What become 1? Negative 1 pi if you flip them, right? So where's that negative 1 pi? Negative 1 pi, right? So as you may notice in there, it would look like such. Are we good, guys? Alright, thank you.
Salud.
So that would be the what? The graph of our cosine function. Are we good? Right. And the last one for tangent. So how do we consider making tangent 1 to 1? What are we gonna do? What part of the graph do we consider? Well, we can consider just this part of the graph, right? If you draw any horizontal line in there, it will make it 1 to 1, right? Cross 1, right? Now in there, what do you think is the domain? Negative pi over 2 to pi over 2, alright? Very good. What do you think is the range for that? So as you may notice, this goes infinitely up because of the vertical asymptote. This goes infinitely down also because of the vertical asymptote, right? With that being said, what's the range for this? Negative to positive infinity, right? Sure. All real numbers, okay? In interval notation once again. So we're gonna flip that one in here. So with that being said, the domain in here will be what? The negative to positive infinity. We good? Right? And the range will be what? Negative pi over 2. Thank you. To pi over 2. Right? Oops. Including. Oh, no. Sorry for that. Okay. This should be what? Parenthesis instead. Okay. It should not include those two because these are what? Vertical asymptotes a while ago, right? So as you may notice, a while ago we put in here bracket. That means those two values are included. But in here, since those are vertical asymptotes a while ago, they're asymptoting. Are we good? So with that being said, how to graph this? We're gonna put an asymptote on the pi over 2 and negative pi over 2, right? And graph it as such, right? So how do we graph that in there? How does it look like? Let's verify. So in here, it should look like that, right? Are we good, guys? Get it? Okay. For the tangent inverse. Any questions regarding what we did on how to analyze them? Okay. Now with that being said, let us now answer some questions regarding these, okay? So, we got one question in here, like such, okay? So, the first question is this. On your section exercises, it says the following. Number 9. It says on number 9, what's the sign inverse of negative 1/2? What's the sign inverse?
Want me to keep recording this?
Oh yeah, please do stop.